Another example for the spherical coordinate system, another example for the generalized curvilinear coordinates is the spherical coordinate system, where we have r, theta, and phi as our spherical coordinates. We can go from Cartesian coordinates to spherical coordinates as r is equal to square root x squared plus y squared plus z squared. Phi is equal to cosine inverse x divided by square root x squared plus y squared. And theta is equal to cosine inverse z divided by square root of x squared plus y squared plus z squared. And the x component is now r sine theta, which takes the projection of r onto the xy plane, and then the projection on the x-axis is cosine phi. R sine theta projection onto xy plane, and this time projection onto y-axis is sine phi, and z is equal to r cosine theta, that is the projection of r onto the z-axis. Okay, so those are the set of transformation equations between these two coordinate systems. The unit vectors are obtained by changing phi, r, and theta slightly, and it's er hat, e phi hat, and e theta hat. They all depend on the position, and they are orthonormal unit vectors, so their dot product is 0 unless they are this. We're taking the dot product with itself, which is 1. And if P is on the z-axis, if the point P is on the z-axis, E theta hat and E phi hat will not be defined, so they will be undefined, so we can just use the z coordinate. Now, what is the position vector in spherical coordinates? Position vector is r E r hat, and any vector v will have a component on the radial axis vr er hat, a component on the polar axis, polar angle, v theta e theta hat, and on the azimuthal axis v phi e phi hat. So here we find the components. Vr, the component on the radial axis is v dot er hat. Component on the polar axis is v dot e theta hat, and on the azimuthal axis is v dot e phi hat. And if we follow the cross product of these three unit vectors, we see that er hat cross product with e theta hat is e phi hat. And e theta hat cross product with e phi hat, using the right hand rule, the four fingers point in theta hat direction, and we curl the four fingers towards e phi hat. Our thumb points in er hat direction, and e phi hat cross with er hat gives us also e theta hat. So er hat cross e theta hat is e phi hat. E theta hat cross e phi hat is er hat, and e phi hat cross er hat is e theta hat. So we see that r, theta, and phi form this right-handed coordinate system. So that's the positive direction for clockwise direction is the positive direction for calculation of cross products between unit vectors. Okay, so we have introduced now the spherical coordinate system with coordinates r, theta, and phi, radial axis, polar axis, azimuthal axis. The transformations between the Cartesian and spherical coordinates is square root of x squared plus y squared plus z squared. This is the radius of a sphere centered at point O, the origin. Phi is cosine inverse x over square root of x squared plus y squared. So this is x and this is y. So this is hypotenuse square root x squared plus y squared. So cosine inverse x over square root x squared plus y squared gives us y, phi, and for z we have r cosine theta is z, which means theta is cosine inverse z over r, which is square root of x squared plus y squared plus z squared. Or we can go from spherical coordinates to Cartesian coordinates. R sine theta takes us to the xy plane, cosine phi projection on x-axis, sine phi projection on y-axis. If we just multiply r with cosine theta, we project it onto the z-axis. The unit vectors er hat, e theta hat, e phi hat are position dependent, but they're orthonormal to each other. Dot product is 0 unless we have the two vectors being the same, equal, in which case it's ones because they're unit vectors. If this point P is on the z-axis, then theta hat and phi hat, e theta hat, e phi hat are not defined. The position vector can just be found by r e r hat, and any vector will have r theta and phi components. And on the other hand, the cross product between these unit vectors, r hat, theta hat, and phi hat, it follows these cyclic permutations so that, for example, e r hat cross e theta hat is e phi hat. E theta hat cross e phi hat is e r hat, etc. So with this, r theta and phi form a right-handed system.